Hey people, how are you? This is Rodrigo, your host, and this is Dapr in action. And today we're gonna see the service to service invocation building block. Since there are sometimes when we need to communicate between services in an synchronous way instead of asynchronous, we can do it synchronously, meaning that we send this request and we expect to receive a response. And I think this is a common practice. There's nothing wrong with communicating your microservices or components in a synchronous way. Okay. Of course, there are some few drawbacks if you do that. For instance, there's temporal coupling between those two services. But yeah, I believe software architecture is all about trade offs, and sometimes you have to communicate between those two services. And that's why today we're going to see the service to service invocation building block or service to service communication building block, also known as the service invocation building block. So before we go ahead, let me show you the thing that we did in the past in the other session when we were practicing with the pop sub in building block. And let me show you the code that I was building, which is this my Visual Studio instance? It is not. This is the one. So you might remember that I created my service A and my service B, right? And I was trying to send this message from service A to service B. But of course, service A doesn't know anything about service B, right? It doesn't know who's going to be the one that is going to receive the messages. It could be service B, service C, service D, or all of them. Okay? So you might remember that I included sales controller, and I'm using the Dapr client object for sending this message by using the publish event async method. And I'm using this name, which is the name of the pop sub component as configured in my machine. I'm using the default configuration. So let me expand my terminal. You might remember that we have in your home folder, right? And then .dapr. And here inside components, we can see there's a component named PopSub, and there's another one for saving state that we're going to see in a following session. However, this component inside popsub.yaml, which is of kind component, this is the one that I'm using by default when I'm trying to communicate between those two services, okay? This is just a reminder of the PopSub thing that we did in the past. The thing is that the name is PopSub, and that's why I'm using PopSub here, and then the name of the topic, and you specify a payload, and basically that's it. That's it, right? You're sending this message with this particular payload to the middleware that is configured, your message broker, which is in this case Redis, that is running as a Docker container, right? So I can go ahead and type Docker PS, and this is running. You can see here Redis. So far, so good, right? So far, so good. So the thing about this is that some code was missing here in the receiving part, okay? And here I'm using, of course, the Dapr client as well, which is not completely required. I'm just showing you that you can inject Dapr client everywhere. And I'm using this topic attribute. And this is the one that you can use for exposing an endpoint that is going to receive the message, right? So the first So the first parameter is the name of the PubSub component, and then the sales string specifies the topic name. So I'm sending a message to sales, and this one is receiving messages from sales, right? So far, so good. And speaking of program.cs, in the receiving part, you have to specify use cloud events. And if you're going to use this topic attribute, you can use map subscribe handler, which is the way that you tell Dapr, hey, Dapr, let's go ahead and find all of those methods that I have that are able to receive messages. Okay, those two lines, 21 and 22, are the responsibles for receiving the message. And I showed you how you can, is this Redis Commander? I showed you that you can use something like Redis Commander for inspecting the middleware, in this case Redis, right? This is a tool that we use for inspecting and connecting to Redis, and it'll taking a look at those messages that we have. So in this case, I sent 2 messages. Those 2 messages are inside this sales topic, and everything is working as expected. Okay. Now you need to run, of course, the receiving part. So you can go to let's go here and PubSub, and then my service B, and here I can, use Dapr run, and then Dapr HTTP port, and then pass .NET run, and pass the required parameters. Okay. So this is the missing part from last session, this topic attribute. And with this, you can receive those messages. Okay, perfect. Now, let's go ahead and jump right into the service invocation topic, which is, as I mentioned before, is the way that we use for communicating between services in a direct way, because sometimes you have to do that. Don't over-engineer your solutions, my friends, okay? So sometimes communicating between services in a synchronous way is perfectly valid. Don't be afraid of doing this, okay? Okay, let's go ahead and see what's going on here. Let's say that you need to communicate between service A to service B in a synchronous way. How do you do that without Dapr, right? How do you do that today without Dapr? So sometimes you do something like, if you're using C#, right? Let's say bar HTTP client equals new HTTP client, and then pass the URL, right? Just like this. And then HTTP client get string async or post async or whatever floats your boat, right? However, what in the world is URL? What's the value of URL? Meaning that service B can have multiple replicas. So service B could have, I don't know, 3 replicas, 5 replicas, 10 replicas. Who knows? So if you do this, of course, we can, if you are a .NET developer, we can discuss if this is the best way. Of course, you can inject the HTTP client factory interface and so on. I'm not discussing HTTP client best practices right now. Just imagine that you need to communicate between those 2 services, and service B has many replicas. How do you do this? What's URL? This is a problem, right? Because you need a way to identify those URLs, those IP addresses and ports, which is not quite easy to do, to be honest with you. So this is how we can do this without Dapr. And with Dapr, we use the sidecar, of course. So you remember that Dapr runs as a sidecar, is a design pattern, right? Is running alongside your main application. So at the end of the day, each service has a Dapr sidecar. So that's why you use the sidecars for communicating directly. In other words, you don't communicate between service A and service B. You say to your own Dapr sidecar, hey, Dapr, I want to communicate to service B. Go and do that. Okay? You're commanding the Dapr sidecar to do it for you. So you send this message to the Dapr sidecar, and the Dapr sidecar is going to use a name resolution component that is configured when you initialize Dapr. If you're running on a self-hosted mode, in this case, it's going to use the local DNS service that your machine has. And if you're running in Kubernetes, it's going to use Kubernetes DNS. I'm going to talk about a little bit later about that. Okay. So the thing is that you need this name resolution service or component responsible for telling you, hey, you know what? Service B is running in this address and port. Okay. This is the responsible. So then you send, or not you, but the Dapr sidecar sends a message and sends this request to this other Dapr sidecar, the one from service B. Okay. So you can see here that the Dapr communication happens in gRPC. It's going to use this technology for performance reasons. I mean, between those two Dapr sidecars, gRPC is the technology that is going to be used. And it's going to use MTLS, mutual TLS, for data security between those two Dapr sidecar instances. And then it's going to send the request to the service B. Service B receives the request. In other words, receives the request, the intention, the thing that you want to invoke from service B, and then service B invokes the thing, and it's going to send the request, the response back to service A. Okay? So you can see that some other parts are involved. It's not as easy as just, service A to service B. The Dapr sidecars are involved, and the name resolution service is involved here as well. So what are some features about this platform, about the service invocation building block? The first one is that you can swap that service discovery component. This one, the name resolution service or component or platform, you can change it. Okay. For instance, you may want to use, I don't know. You can use console. You can use SQLite. Those two concrete implementations are available right now. So console, HashiCorp's console is quite popular technology. And it's actually the main goal about console is doing this, right? A service discovery platform, highly available for distributed applications. The other feature is resiliency, because what can happen if service B goes down? What happens in that case? Can you imagine? Can you imagine that in your solutions you have something like this, and service B throws an exception or goes down, or not even the service B, but the server that is hosting service B? What happens? So luckily, we have the resiliency feature baked into the service invocation building block. So you can specify some policies for resiliency, such as automatic retries with backup time periods, or timeouts, and so on and so on. I'm going to talk about that in a little bit. The other feature is tracing and metrics. So all calls are traced into the configured tracing platform that you have in place. You can configure your tracing target, meaning you can use Zipkin, you can use New Relic, you can use Jaeger, you can use whatever floats your boat, and all calls are traced, and also metrics are stored in that particular platform, which is fantastic because I believe that's one of the things that we software architects and developers we forget most of the time. You know, I wish it wasn't true, but it's true. Sometimes we totally forget about tracing and metrics and observability components for our applications. So this is great. And mutual TLS, as I mentioned before, the communication between those two components happens by using mutual TLS. So this is a secure communication between those two microservices. And finally, you can also use access control policies for specifying, who can invoke which method in your solutions. Okay, it's not that you open everything and all of a sudden everything's open. Of course, you can do that, but you can also have this granular control over who and what access those methods and services. This is marvelous, right? This is fantastic because, as you can see and as you can hear, service invocation has those things that we have to implement ourselves without using something like Dapr. So speaking a little bit more about the named resolution service, the service discovery thing, if you use the self-hosted mode, just like I do in this Dapr in Action webinars, I'm using the multicast DNS component that is inside my Windows operating system. So you don't need to do anything else to make it work. It just works, okay? And if you're running Dapr inside Kubernetes, then it's going to use Kubernetes DNS by default. And also, you don't need to configure anything else. It just works out of the box, which is fantastic, right? So those two are the default implementations of the DNS service that is going to give you the correct IP addresses and ports of those target services. Speaking about resiliency, as I was mentioning before, you can apply resiliency policies, okay? There's a resiliency object that you have to specify inside a YAML file. In the self-hosted mode, the name should be resiliency.yaml. And if you're running on Kubernetes, then Dapr is going to find the name resiliency specs used by the applications. And as I was mentioning before, there are some patterns that you can implement, right? Such as timeouts, retries with backups, and circuit breakers, and so on. And actually, I'm going to show you the documentation about the resiliency schema so we can create our own resiliency.yaml file and test this out. Okay, so if you want to remember, Dapr is exposing this API, and if you want to execute or use the service invocation building block, this is the endpoint, okay? v1.0 invoke. And then you pass the name of the application and then the name of the method that you want to execute. I don't think that's a compelling way of using Dapr, remember that we're using the Dapr SDK, and I think that's the way to go. Of course, it depends on the availability of an SDK for your development platform. Okay, so far so good. Let me change the window to this place. So this was running Redis Commander. Let me change the path to Dapr in action, because I happen to have this couple of projects that I created half an hour ago. So those two were created by using .NET New Web API, and that's it. Okay, that is it. Service A, Service B, those two are inside the same solution. So I'm gonna open up Visual Studio. Please hold on. I'm gonna open that same solution here, and I'm using this second monitor, and it's ready to go. This is it, okay? So let's see how we can use the service invocation building block. Let's say that service B has, I don't know, it always has weather forecast. It's so cheesy, right? Weather forecast. Anyway, I think we can use that. I think we can totally reuse weather forecast. Since I don't want to add some additional logic, I just want to, invoke this get weather forecast endpoint. So let me see. Service B, .NET Run. So this is gonna build the solution, and then it's gonna expose this endpoint, right? And here I can say, is that get weather forecast? Is that the name? Weather forecast. So weather forecast / get weather forecast. Am I missing something? Service B, weather forecast, controller, root. Weather forecast, weather forecast. Am I missing something? Anyway, I'm gonna use this. Maybe I'm not running the application correctly. Service to service, service B, Dapr in action, localhost. Is this the correct? Yeah, I think this is it. Get weather forecast. Something is wrong with my URL. Anyway, I don't wanna, maybe the answer will come up in a little bit. The thing is that now I wanna add Dapr ASP Net Core. Remember, this is the SDK. Browse Dapr ASP.NET Core. Nowadays, the latest version of Dapr is 1.14, but I think in a couple of weeks we can have 1.15. Anyway, so here, let's see. I wanna add. Let's change this name to query controller. Query controller. Okay, and let's delete everything this way, right? So HTTP GET query, and here I want to invoke service B. This is what I want to do, okay? So I'm going to use the Dapr client object. That's why I'm going to use the primary constructor, Dapr client, and here I want to use Dapr client, okay? So thankfully, to this SDK, we can use invoke method async. Just like you're watching here, invoke method async, we have a couple of options. The one that is the regular one, and the other that is a generic version of invoke method async. Okay, so you pass the payload that you're expecting to receive. So in this case, I'm expecting to receive weather forecast, right? Because this is actually an enumerable of weather forecast. This is the object that this service is returning, right? Very easy thing to grasp. Let's go here and enumerable of weather forecast. Of course, I'm kind of reusing the existing classes here. Since I'm reusing weather forecast, I don't want to create another, model class, or I don't want to create a domain model or something, because we don't have time today to do that. I'm sorry. And I'm choking here. And luckily, weather forecast, this has the same structure as this other class, right? Because it comes from the template. So that is it. I think that is it. Of course, we need to change temperature. Let's make it get set, because in the traditional temperature in Fahrenheit, it's just using this, right? So let's say that we have this model class and I want to reuse this. And here you need to specify the application ID name, say service B, and then the method name. The method name is going to be, let's see, it's going to be get. I think that is it, right? Or get weather forecast. Let me go ahead and change this. And let's go and fix this, because otherwise I'm going to have some problems. So let me go back to the terminal and do this .NET build. And I removed the HTTP gets string. So .NET run. I want it to run on get weather forecast, and that's it. This is my goal right now. So this is running, and weather forecast, this is it, right? It's working. So this is the name of the method that I want to invoke from this service B instance. So weather forecast is name, okay? And you can also pass a cancellation token, which is the best practice. However, I don't want to do this in this particular session. And I think that is it. Bar result is going to be await this. Of course, this has to be async task of enumerable of weather forecast, just as we're expecting. And I can go ahead and return okay result, and that's it. Okay. Is this result an enumerable of weather forecast? Yes. Okay. Cannot implicitly convert. Yeah. Async. What is the interface? Action result of enumerable of weather forecast. Is that action result, or this? This is better. The concrete implementation of the action result, action result interface. Anyway, you can see that I'm using the invoke method. I'm not using HTTP client or HTTP client factory or your own programming language, HTTP idiom, right? You're just using the invoke method that comes from the SDK, and that's it. So it looks like this is complete. This is invoking this method that we have here. And let me see if I can reuse, I can refactor this into a primary constructor. And I think that's it. Now, let's go back to the material and to the training content, since I want to mention how we can execute Dapr applications. You have to remember that you have to pass, if you're using Dapr run, the app ID flag, and then the Dapr HTTP port, or if you happen to be using gRPC, then you have to specify the gRPC port. This is for the sidecar, and then the app port number that your application is using, of course. That's why you can use the URLs flag if you happen to be using .NET, so you have more control over the port that your application is using. And then the separator, right? Double dash, and then your specific instructions for running the application, such as .NET run, and then the URLs flag, and so on. And basically that's it, okay? So I wanna copy this since I don't wanna watch you see me typing all the time. So let's go ahead and let's change the folder to service A, and let's name it service A, and let's use 5500, and here 55,000, because I remember that we had some problems with the 5,000 port. And then, yes, 5500, right? So this is service A. Okay, there is an error. Type or namespace name Dapr client couldn't be found. Is that right? What's going on here? So rebuild. Yes, I have that same error. Okay. I had to compile the application. Let's try again. Dapr run, specify the application name, the ports, and that's it. Okay, so this is running. And then let's do the same with service B. So Dapr in action, and Dapr run service B, which is right here. And then Dapr run app ID service B. I'm running the sidecar, right? Hopefully this makes sense, since I'm not communicating between those two services directly. I'm running those sidecars, right? I'm doing this precisely, right? I'm executing my service A with the sidecar, and then service B with its sidecar as well, right? And then all the magic happens thanks to the service invocation building block. So let's use, I don't know, 5501 and then 55,001, and just like this. And hopefully this works, because I don't remember compiling the application. So actually, tell you what, let me try again, .NET build, and let's do this. Okay, so at this moment, I have both services running in my application, in my computer, as a self-hosted mode, and each service has its own sidecar. That's why I have a couple of, tabs here in the Windows terminal. I'm using Dapr run each time because I'm not using the file similar to Docker Compose. We're gonna do that in a following session. However, my goal here today is to show you how the service invocation building block works. So that said, let's go ahead and let's try to run the service invocation building block. I'm sorry, the service A instance. Hello, my friend Lanka. How are you? So, okay, so 5100, can I do this? Localhost 5500 and query, right? You might remember that we have the query controller. Let's go back here. We have the query controller. So with this syntax, if you're not an ASP.NET Core developer, this syntax is going to use the prefix of the class name. In other words, it's going to use query, which is a prefix before controller. That is actually the syntax that we use in ASP.NET Core. Maybe if you're a Python developer or maybe another programming language developer, this actually is kind of weird, but this is happening. And with this attribute, this is a query endpoint. I'm glad, Lanka. I'm glad. So curl and enable to resolve service for type Dapr client. Yes, of course, something is missing. So what's missing, my friends? Can you tell me? So the thing is that I didn't add the Dapr client object here. Of course, I included the NuGet package right here. However, that's not enough. You need to add Dapr, Dapr, and that is it. Okay, let me rebuild service A. Let's go back to the terminal. Service A. Let's try this again. And service B. Actually, stopping service B wasn't necessary. I just needed to rebuild service A. So all of those services are running right now, curl, and this is returning the payload from service B because service A used the sidecar and the sidecar communicated to service B's sidecar. And this is actually what's happening today. This diagram, my friends. Okay. So speaking about the name resolution component, as I mentioned before, you don't have to do anything additional. It just works out of the box. And that is fantastic. This is glorious, right? Perfect. So now let's talk about, let's see if we can create a resiliency policy. So I want to show you this thing, the resiliency policy. So let's go ahead and open, I don't remember the schema, of course. And I know what I have to tell you right now. Before I try to implement the resiliency policy, I need to explain a little bit more about the configuration that we have in Dapr. Okay, so we can see that this is working. It's just like magic, thanks to our Dapr friends. And thankfully, this works fantastic. So you might remember that we have the home folder. Is that home folder? Oh my God, what happens today with my fingers? .dapr. And here you can find all the Dapr binaries, right? So this is the Dapr folder in your machine. And you can find a file named config.yaml. Config.yaml. So this is quite critical, okay? Configuration is this object, okay? You can see that I'm using API version, kind, metadata, and spec, similar to what we do in Kubernetes. So this is a configuration object for Dapr. And inside the spec, you can see that this is specifying the tracing configuration. And for tracing, it's using Zipkin, right? We can see that Zipkin endpoint address, and this is pointing to this local host 94.11 and so on, right? And this is because if I type docker ps, I'm also running Zipkin. So I didn't do this. It was the Dapr initialization process that pulled zipkin image, the zipkin image, and then run zipkin as a container in my machine. So this is fantastic, and I'm using the service invocation building block. And how in the world is this connected to what I'm explaining today about the Dapr invocation building block and the configuration? I'm sorry, config.yaml. So the thing is that inside this this file, you can edit this file, or you can take this configuration and put it in your source control, and you can configure different things and different features for your Dapr installation. So for instance, I'm configuring tracing here, but you can also configure the metrics feature. You can also configure the name resolution component, and many things. So let me see if I can Dapr configuration, config.yaml. Let's see if I can find this. And this is it. So we can configure tracing, metrics, logging, middleware, name resolution, scope secret store access, and so on. I'm not going to read the entire list here. So you can see that this is the place where we can do this. Okay. So tracing is pre-configured thanks to the Dapr initialization process, meaning that all the communication that is happening between those two services is being traced. How can I show you this? You may be asking. Let's try this again. Docker PS, zipkin is running inside my computer. Is using this port 9411. So let me go ahead and navigate to localhost this port. Is this the port number, zipkin? 9410. I think it's this other one. Localhost 9410, no, 9411. Zipkin. I think something is missing. No, 9411. And I don't know what's going on here. The thing is that this is being configured thanks to this configuration. And of course, I'm going to show you the observability options for Dapr in a following session. And today, I just want to show you this configuration. This is the place, okay? 9411. I don't think this is running. I don't know why. It should be running. And I could be, oh, this is running. So /zipkin. This is it. I was trying to reach the root endpoint, and it's actually /zipkin, just like this. And if I do this, zipkin is this telemetry and traceability platform that is obtaining that information that is happening in my computer, okay, between those two services. And if I show you all of the different things that are happening, so let me see if I can find service A, service B. Well, I have those here, and I don't know what's going on. And the thing is that everything is being logged here. Somehow I'm missing something. However, this is not the thing that I want to show you. The thing that I want to show you is the resiliency policies that we can configure. So let's go back here and let me see if I can remember where is this. So resiliency. Let me go back here. Access control. Let me see if I can. No. Let me see. Dapr resiliency. We go back here. So this is the resiliency service to service, and this is it. Yes. As I was mentioning before, what happens if service B goes down, right? How do you manage that? Thankfully, the resiliency policy is something that you can configure outside your application. So you can see that we need to pass a resiliency object, just like the one that I'm showing you here. And let me expand this, okay? And inside this resiliency object, you have to specify the different policies that are available, such as retries, circuit breakers, and timeouts. I think we can see. Let me duplicate this, and here, let me go back. Resiliency, service to service. I want to show you the entire schema. Anyway, I think this is enough for today. Retries, circuit breakers, and then timeouts, which is not here. You have to specify those policies, and then you can specify, check this out. Here, down below, you can specify the name of the application that you're want to apply those policies to, right? For instance, this schema is creating this retry forever, right? Retry forever, and this is configuring this policy for retries. Okay, constant, max interval, max retries forever. So this is gonna retry forever, right? And this other policy is the name is simple CB. It could be Batman or it could be Spider-Man. The name actually is something that you can change. And then max requests, timeout, and trip. You have to specify those values. And there are some other values if you happen to read the entire documentation. And then you use that policy here for your specific service instance. So let me try this. I didn't do this beforehand, so it doesn't matter. I'm not fearing anything right now. Let's try this, friends. We are developers, right? So let's stop this and this. And let me see. What if we create, I don't know, config, and then config, and then resiliency.yaml. Let's create this file, paste the entire thing, right? I'm using YAML because, you only live once. My resiliency, I think those values are perfect. And I'm gonna use the same names as I mentioned before. This could be Batman, right? And of course, you have to change the name here as well. And let me change the name of the application. So service B, okay? This is the app ID, friends, okay? So it has to match. So in other words, for that, in the documentation, there's an order processor thing or application that you should run to make it work. And in our case, we have service B. And I think that is it. That is it. We have our resiliency.yaml file, and then we need to pass the folder where this application has the scripts, right? We can do that by using resources path, just like this. So resources path. So let me go back here to the terminal. And let's try this again. So service A is going to be this Dapr run, service A, 5500, and this is running, right? And this is service A, okay? This is going to be service B then, right? Because I used this other tab. Anyway, service B, is going to be this. Oh no, I don't have the previous command. Anyway, I have to change it. Service B 5501, 55,001, and just like this. And remember, resources path. Is that right? Resources path, and then one level above, right? And config, and that's it. I think this is the the relative path for pointing to that config folder that I just created that has the resiliency.yaml file. And that is it. Oh, I'm sorry. Oh no. Oh no, I lost everything. Let me try this again. 55,001 and this, and resources path, and then config, and this is it, right? So in other words, service B now is running with those policies in place. I'm configuring, the resiliency policies for service B, meaning that if something fails, then it's gonna the client service is gonna retry. So let me go back here and is that curl? Where is it? Curl. This is running, right? This is running. And what happens if I do this? And then you can see that this is not returning immediately. Oh no, maybe there's something wrong. It's returning. So let me try this again. So this is running, yes. Or maybe I should use, yes, I'm using that resources path in this other way. Let me try this again, friends. Dapr, this is service A, this is running correctly. This is service B, curl, this is behaving correctly. This is service B, and is this gonna return something, or is just waiting? It's just retrying, right? So there's something wrong. My point is that maybe I'm not using the resources path correctly, right? So I'm using resources path in service B, but maybe I should use that in service A instead. So resources path, and then config, right? So this is running. Let's reuse that. I don't think that is gonna change anything about service B, right? So if I go back here, curl is gonna work. Yeah, it's running, right? And this is service B. Let me stop service B, try this again. And is this gonna retry? Is this configured correctly? Is my resiliency.yaml file correct? It looks like this is logging something, right? It's logging something. And let me try with this policy again, try curl. And this is running. This is running, and this is running as well. And now I'm receiving the data again. Interesting. There are so many questions that I have about the retry policies and the process that I'm using. However, remember, you have to configure the resiliency.yaml file. I think that's done. I'm taking the same code that is inside the um, documentation right here, right? And you have to create the resiliency.yaml file. You have to pass that to your Dapr run command. You have to specify the folder where this resiliency.yaml file is. And I think that is it, right? That is it. So with that, there are so many options about service invocation. I'm just scratching the surface here. And so you can see that the initial and most basic usage of the service invocation building block works marvelously, right? It's just fantastic. You don't have to do anything else. But of course, you can configure a lot of different things. And I'm just realizing that there is a slide that is missing here in my deck. I don't know what happened to my latest PowerPoint slide. Anyway, it doesn't matter. What matters, friends, is that you can configure your service invocation building block in this way and in this fashion, and you don't have to do anything else to make it work. And I think that is fantastic, right? That is fantastic, and we're seeing that this is sending data to Zipkin, right? Maybe it's because I'm just using, the public 5500 endpoint instead of using the sidecar, but I don't believe that is the reason why. Anyway, remember, the main point here is that you can use this in a very straightforward fashion. I actually just included Dapr client and used invoke method async. That is the most basic thing, right? The configuration around the service invocation building block is the most advanced thing about this building block. And of course, tracing, we're going to see that in a following session. Also metrics, and also resiliency, because resiliency is not only for the service invocation building block, it's also for the state management building block and some others. So we're going to revisit this code and the policies, and we're going to reuse the same topics in a following session. Okay, so yes, this is not my latest PowerPoint slide. I think there are a couple of things missing here. I had a slide talking about the resiliency policies and the YAML file. However, I think this is enough for today, my friends. If you happen to celebrate Christmas, Merry Christmas. If you don't, it's okay. Merry Christmas as well. And see you next Monday. Okay, I'm Rodrigo. I'm your host, and this is Dapr in Action. See you next Monday.